Hello everyone, welcome to the course of computer networks. And today's topic of discussion is about the subnetting. That is, we are going to see the subnetting in detail. Previously, I have covered two lectures that is on the IPv4, that is Internet Protocol version 4, and the subnet mask there. So in that, we have discussed about introduction part to the subnetting. Now, today we are going to have a discussion in a detail about the subnetting, how to do the subnetting, and how to calculate the values of the subnet mask for the subnetworks there. So, the content of this lecture is as follows. First of all, we are going to see the introduction part about the subnetting. Then we will see the steps for calculating the subnet mask for the subnetworks. So that is particularly related to the subnetting algorithm there. Then we will see the calculation with an example for the subnetworks there. So the objective of this particular lecture is to understand the fundamentals of IP addressing and the need of subnetting. So subnetting is required for efficiently using the IP addresses in the network. That is to optimize the use of the IP addressing there depending upon the number of hosts there. Secondly, to explore the subnet mask and how they impact network segmentation, and also to gain the knowledge of different subnetting techniques used in networking there. So after the this lecture, the students will be able to explain the purpose and the advantage of subnetting in the network design there. They will be able to calculate the subnet mask and determine the network and host portion of an IP address is there. They can easily design subnetted network based on the given IP addressing requirement. That is, upon the basis of the requirement, they can handle this particular network and they can subdivide it related to the subnet mask there. Also, they can demonstrate the ability to troubleshoot and verify the subnet configuration. So, as discussed, subnetting is used for dividing a network into two or more networks. That is called subnetting. Okay. So, or we can say that logical subdivision of an IP addressing. So when a computer, that is a particular device that belong to a subnetwork, they are addressed with an identical most significant bits group in their IP addresses there. Let us understand this part of subnetting with an example. Here are two IP addresses which I have taken of class A there. The first IP address is 10.10.1 and another IP is 10.10.10.9 there. Okay. And what we are doing here, we are using these two IP addresses and we are seeing that whether these two IP addresses belong to the same network or to the different network. Now, when assigning the IP address to the particular device, we have to provide a default mask there, or you can say that a subnet mask. So for the class A, because this is an example of class A, these two IP addresses, that's why the default mask is 255.0.0.0. But for the class A, we can also use the default mask of class B and the default subnet mask of the class C there. Now, in my previous lecture, I have told you how to find out the network by using the subnet mask. So what we have to do, the IP address which has been provided to us, that is 10.10.10.1. We will convert this first of all IP address into a binary format there. Okay, we will convert it into a binary format. Similarly, if we are using the default subnet mask for the class A, then the IP address for the default subnet mask is 255.0.0.0. Again, we will convert it into a binary format there. After that, to find out the network address, what we do? We do a bit by bit AND operation between the bits there. So you know that when you are going to convert this 1 into binary, that is equivalent to 8 bits, and this 0, 2, and 8 bits, we are going to have a 0 over here. Again, 0 when will be ANDed with a binary format of 10, 0. here will be 0, and when this number 255 will be ANDed with the decimal number 10, then we are going to have a 10 there. So remember that we are doing an AND operation over. So here the network address comes out to be this 10.0.0.0. Similarly, when we will use this IP address 10.10.10.9, again, if I am going to use the default subnet mask, the same network address will come out for this IP address also. That means these two IP addresses belong to the same network, that is 10.0.0.0 there. Okay, so now let us see this. If I am using this default address, okay, this subnet mask. So now let us take 10.10.10.9 is here. I am doing an AND operation with the default with the subnet mask 255.255.255.0. So when you are going to an AND operation, you will get 0 over here because 0.9 will give us 0. 250 when ANDed with decimal number 10, you are going to have a 10. Over here, you are again going to have a 10. Over here, you are going to have a 10 there. Okay. So now the network address is 10.10.10.0 there for this IP address. When you will use this IP address, then again you will get the same network address 10.10.10.0. So by these example, it is clear that by using the default subnet mask of class C, class B, and class A for the class A IP addresses, these two IP addresses belong to the same network there. Okay. Now, if you are using this particular mask, that is 255.255.255.248, then these two IP addresses will belong to the different network. This is the subnet. Okay. Now, see over here, I was having in my network two IP addresses. Okay. Two IP addresses were there. When I was using the IP addresses, that is all these three IP addresses, two devices were in the same network. But when I use the concept of subnetting, the default subnet mask changes to 255.255.255.248. Then these two IP addresses are divided. Now they do not belong to the same network, they belong to the different network. This is how we are doing the subnetting. Don't worry about that, how this particular subnet mask comes out to be. We will see that with the particular algorithm and by using the example there. Okay, so subnetting algorithm now. So first of all, what you have to do, you have to identify the class of an IP address there, and you have to note the default subnet mask. Then what we will do, we will convert that particular default subnet mask into a binary. This is the step number 2 over here. Okay, this is step number 2. After the step number 2, what we have to do, we have to note down the number of hosts required per subnet, right? And then we will find the subnet generator. Okay, and octet position. Octet position of what? Of the subnet generator. And from this particular subnet generator and octet position, we will generate the new subnet mask there. This will be the fourth step. And by using this subnet generator, we can generate the network ranges, that is subnetworks in the appropriate octet position there. Okay. So what are these 5 steps? First, you have to identify the class of an IP address and note down its default subnet mask. Then in the second step, we will convert that default subnet mask, which is in a decimal dotted notation, to a binary notation. In a step number 3, we will note down the number of hosts required per subnet. Then we will calculate the value of subnet generator and the octet position in which this subnet generator is present there. Then step number 4, we will generate the new subnet mask. And the step number 5, we will use the subnet generator and generate the network ranges in the appropriate octet position. So we will take one example related to this particular algorithm, how to calculate the subnet mask, how to find out the ranges of the networks there. So look on this particular example. We are going to subnet the IP address, that is 212.12.7.0 into 30 host. Okay, into 30 host. Now, what the step number one says? The step number says the IP address which has been given in the question. First of all, identify the class of that particular IP address, and we have to note down the default subnet mask there. So if we see this particular IP address, this IP address belongs to class C there. Okay, belongs to class C, because we know that in the first octet, that is in the first octet, if the number comes from 192 to 223, then this belongs to the class C there. So we have number 212. That's why this belongs to the class C. So step number one is what? Step number one is, we have identified that this particular IP address belongs to class C there. So we will note it down, class C. And for the class C, the default subnet mask is 255.255.255.0. Okay, so this is the first step. Now in the second step, what we have to do, we have to convert this decimal noted subnet mask to binary. Okay, so we are going to convert it into a binary there. So now how what will be the binary of this decimal noted notation there? This is 1 1 1 8 times 1 1 2 3 4 6 7 and 8. This is first octet. Then in second octet, again we have a value 255. That's why again 8 ones will be there. So 1 2 3 4 5 6 7 and 8. Then in third octet, again we have a 8 ones, 1 2 3 4 5 6 7 and 8. And in the last octet we have 0 1 2 3 4 5 6 7 and 8 there. So we have converted this particular subnet mask into a binary format there. Now after that, after doing these two steps, the third step is, in the third step, what we have to do? In third step, we have to note down the number of hosts required per network. Okay. So in per network, how many hosts we require? That is 30 hosts. Okay. That is 30 hosts. So we will convert this decimal number 30 into the binary bits there. And we have to write this decimal number 30 into a minimum number of binary bits, which is required for conversion from decimal to binary. So we know that 2 to the power 5 is equals to 32. That means the range is from 0 to 31. That's this, the 30. So the binary conversion of 30 will be 1 1 1 1 0. Okay, 1 1 1 1 and 0. How we come to know that? That is, you can easily convert this decimal number 30 to a binary format in this way. This is done in this way. We have 1 2 4 8 16 and 32. That is 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5 there. Okay. So these are total 6 bits. But what we have to do, we have to write the number into minimum number of bits there. So that is that is we are going to have 5 bits. Okay. So with this 5 bits, with these 5 bits, we are having 1, 1, 1, 1, 0. 16 plus 8, 24 plus 4, 28 plus 2, 30 there. So this is the binary. So how many bits are required? 5 bits are required. Okay. So total 5 bits are required. Now what we will do, we will have to calculate the value of subnet generator. Okay. We have to calculate the value of subnet generator. So how to calculate the value of subnet generator? First of all, note down that these are the 5 bits. So we will use this particular default subnet mask. What we will do from this particular extreme backside, we will count total number of bits 5. 1, 2, 3, 4, and 5. Up to these 5 bits will not be changed. We will not do anything to these 5 bits. Okay. Now we are left with these 3 bits. We will change these 3 bits to 1 there. So now the binary format of the above mask will be 2, 3, 4, 5, 6, 7, and 8. 1, 2, 3, 4, 5, 6, 7, and 8. 1, 2, 3, 4, 5, 6, 7, and 8. And 1, 2, 3. These 5 bits will not be changed there. 1, 2, 3, 4, and 5. Let me repeat it once again. After noting the number of hosts required per network, the value which was given us to 30, we convert that 30 into a minimum number of bits. That is 5 bits are required. So the number becomes 1, 1, 1, 1, 0. Now what we have to do, we will write down this mask in which way? From the back side, we will count the total number of bits 1, 2, 3, 4, and 5. Why 5 bits? Because the number of hosts are required equals to 30 there. Then the new mask is which has been generated is this one which has been shown here. Now to find out the value of subnet generator, okay, we have to find out the value of subnet generator. So how we are going to find out the value of subnet generator? From the back side, what we have to see, where is the first value of 1? Okay, we have to see in this particular octet the first value of 1 there. So the first value of 1 is at this position. Okay, this is at this position. Here it is the first position of the 1. Okay, this is the 1. So what is the value of this 1 in this particular position? That is, we have to use the 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, and 2 to the power 5. So the subnet generator is equals to 2 to the power 5, which is equals to 32 there. Okay. So now see what we have done. After writing the new mask value, how we have written this new mask value? By using these 5 bits from the back side, we have preserved these 5 bits and we have changed rest of the bits to 1 there. Okay. After that, what we are finding out? We are finding out the value of subnet generator. How we are finding it? From this back side, we are seeing that where is the first one. The first one is at the index number 5. That's why 2 to the power 5 is equals to 32. Now, the last value is what? The last value is about the octet position. So the octet position is the value of the subject generator from which position we have got. Okay. So we have got the subnet generator value from this particular octet. Okay, this particular octet. So we have 4 octets in this whole IP address: 1, 2, 3, and 4. So the octet position is equals to 4. Octet position is what? Octet position is equals to 4 there. Okay. So till now what we have done? We have done 3 steps. First of all, we have find out the value of that to which class this IP address belongs. That is to the class C. Then for this class C, we have written down the default subnet mask, that is 255.255.255.0. Then in the step 2, we convert this default subnet mask to a binary notation. We have converted that. Then in the third step, we note down the number of hosts, which is equals to the 30 as per the question. We convert that binary decimal number 30 into a minimum number of bits there. That is, the minimum number of bits required are 5 bits. So the binary is 11110 there. Now, after this, what we have find out? We have find out the new subnet mask. How we have find out the new subnet mask? In the default subnet mask, we will preserve the 5 bits from the backside. Why 5 bits? Because the number of ports is going to have a 5 bits there. Then we will convert all the remaining bits to 1 there. So this is how we have done. And after that, we have find out the value of subnet generator. How we have find out the value of subnet generator? We will see in this particular octet position the value of first one. So the value of first one comes at the position number 5. That's why the subnet generator value is equals to 2 to the power 5 equals to 32 there. Now, after that, we have find out the octet position, which is equals to 4 there. Okay. So till now, what we have done, we have find out the, we have used the this step number 1. We have noted down its default subnet mask. Then we find out the value of host, the minimum number of bits required is 5 bits, subnet generator, and octet position there. So the now new subnet mask becomes 255.255.255.224 or \27. Why? Because the subnet mask which comes out to be is this one. This one. This is the subnet mask. New subnet mask. This is the new subnet mask. So how we are going to write it? We are going to write in this way. This is 1, 2, 8. Then in second also we have 8 ones, 5, 6, 7, and 8. Then in this also we have 1, 2, 3, 4, 5, 6, 7, and 8. And in the last octet we have 3 ones, and the remaining bits are 0, 0, 0, 0, 1, 2, 3, 4, 5. Okay. So this number is 255, 255. This is 255. This is 255. And this number is 224. Why? Because 128 plus 64 plus 32 there. Okay. Why? This is 2 to the power 5, 32, 64, and 2 to the power 7, 128, which comes out to be equals to 224 there. So how many ones are there? There are total 27 ones. That's why \27 there. Now the new range. How we have find out the new range? In the question, the network is starting from 212.12.7.0. So this is the first IP address we have noted down. To this particular IP address, we will add the value of subnet generator, which is equals to 32 there. So the next IP address will start from 216.21.5.32. Then in the third value will be, again we will add 32. The third network will start from 216.21.5.64. Then the fourth network will start from 216.21.5.96, and like so on. We will add the subnet generator 32 to all the coming IP addresses there. So now what we will do, we will find the range for the particular network. So this is the first network, this is second network, this is third network, this is fourth network, this is fifth network. So the first network, the value will go from this particular IP address 216.21.5.0 to 216.21.5.31 there. Okay. This network will start from 216.21.5.32 to 216.31.5.63. Then this third network will start from .64 to 216.21.5.95 there. Okay, this is the. So in this first network, this is the starting IP address and this is the broadcast address. So in between 0 to 31, we will not use these. So we have total how many? We have total 32. And after 32, we will not use two net IP addresses. So the remaining are 30. So how many hosts we were using? 30 hosts. So in each network, now you will see there will be 30 hosts. So in this way, we are going to find out the value of the subnet mask. We are going to find out the value of subnet mask there. And by using that subnet mask and subnet generator, we are finding out the number of networks in that particular network there. Okay. So now you know that in a class C, when we are using the default subnet mask 255.255.255.0, the total number of hosts will be 254. Now, after doing the subnetting, what we are doing? We are dividing whole this network into a subnetworks. In the first network, how many hosts are there? 30. In the second, 30. In the third, we have 30. Like so on, we have divided the whole network. Now, let us take one more example. We have this subnet the IP address 141.15.6.0 into 500 hosts in each network. So let us begin with this example. First of all, we will identify that this IP address belongs to which class. So we have the number 141, which comes under the class B. Okay, so this is an example of class B there. Now, for the class B, the default subnet mask is what? 255.255.0.0. Okay. So in step number 2, we will convert this particular decimal noted subnet mask into a binary format. 1, 2, 3, 4, 5, 6, 7, and 8. Dot 1, 2, 3, 4, 5, 6, 7, and 8. Then 8 zeros, 7 and 8. Then 1, 2, 3, 4, 5, 6, 7, and 8 there. Okay. So we have converted that. After that, in step 3, we note down the number of hosts. So the number of hosts required in a per network is equals to 500. 500 hosts are required. So that means the minimum bits which we required is 9 bits. Okay, because 2 to the power 9 is equals to 512 there. So we have total 9 bits. Now what we will do? We will preserve 9 bits from the back side. From the back side, we will preserve the 9 bits. We will don't change the 9 bits, and rest bits will be changed to 1 there. So from the back side, we will count total 9 bits. So these are the total 8 bits. And this is the 9th bit. Till this, we are not going to change any value there. Rest, we will convert into number of ones there. So this will become 1, 2, 3, 4, 5, 6, 7, and 8. 1, 2, 3, 4, 5, 7, and this bit will not be changed there. Okay, 3, 4, 5, 6, 7, and 8 there. So we have converted this there. Okay, again, for 500 hosts, the minimum bits required are 9 bits, because when we will convert this decimal number 500 into a binary, the minimum number of bits required will be 9 there. What we have done, in the default subnet mask, we preserve the last 9 bits. We are not going to change these 9 bits. Okay, rest bits will be changed to 1 there. This will be the new default mask. Okay, new default subnet mask. Okay, this is the new default subnet mask value. Now, after that, what we do? We find out the value of subnet generator. We will find out the value of subnet generator. How we will going to find out the value of subnet generator? We will see this particular octet now. We will see this particular octet. Okay, in this octet, where is the first one? This is the position of the first one. So this is 2 to the power 0. This is 2 to the power 1. So the value of subnet generator comes out to be equals to 2. And the octet position is equals to 3 there. Octet position is 3. Okay. Again repeating. After finding out the new subnet mask, what we are going to do? We are going to find out the new value of subnet generator, which is equals to 2. Why it is equals it is equals to 2? Because if we have this position of 1, okay, the position of this one we are seeing. The position of this one is 2 to the power 0, 2 to the power 1, which is equals to 2. So this is the value of subnet generator, 2 to the power 1 equals to 2 there. Now, where this subnet generator value is found out? From the third octet. That's why the octet position is equals to 3 there. Okay, octet position is equals to 3. Now what we have to do? After finding out the subnet generator, we have to find out the network ranges. So the network is starting from this one to 141.15.6.0. Okay. What is the subnet generator value? 2. So the next network address will start from 141.15.8.0. Again, to this 8, we will add 2. The third network will start from 114.15.10.10.0. Okay. So in this way, we are finding out the networks here. The next address will come out to be 114.15.12.0. Okay, in this way, we are going to have. Now, the first network will have the IP address 141.15.6.0 to 141.15.7.255. This is the network address range of the first network there. Similarly, second network will be 141. Now see, second network is starting from this IP address 141.15.8.0 to 141.15.9.255. So in this way, we are going to find out the network ranges. So we have divided the each network into how many hosts? Into a 500 hosts there. So in this way, we are having this particular example. So the conclusion of this particular lecture is that subnetting is a fundamental concept in networking that enhances efficiency, security also, and resources management by dividing a large number of network into a smaller and manageable subnetwork. Through this lecture, we explored that the subnetting algorithm, the role of subnet mask, and our practical techniques for segmenting network there. And by mastering subnetting, network administrator can optimize IP address allocation, reduce congestion also, and improve overall network performances. So understanding subnetting is essential for designing scalable and secure networks, making it a crucial skill in the field of networking. The references which I have used, the most benefited books are these three books, that is Gross, Tannenbaum, and Frozen. You can after go for the online resources also. That is, if you want to go, that is for an IPv4 and IPv6 standards, then networking concept by a Cisco networking network, and the research papers related to the networking, that is Peterson, LL, and Davy, which was given in 2011 for the computer networks, and various IEEE and ACM publication on IP and networking. Thank you and have a nice day. Thank you.